In March 2023, a single mutable Git tag brings down the security posture of over 23,000 repositories. The tj-action/changed files action, trusted, widely used, and seemingly safe, is silently compromised. Malicious JavaScript runs inside thousands of CI pipelines, printing secrets directly to workflow logs. No pull request is opened, no alert fires, no diff is visible to any downstream team. The attack vector is not a zero-day vulnerability or sophisticated exploit, it is simply the assumption that a tag will always point to the same code. Every GitHub Actions workflow receives a GitHub_token automatically, but most developers never inspect what that token can actually do. By default, it holds write access to repository contents, pull requests, and issues. That means a compromised action dependency can push code to your branches, auto-merge pull requests, or silently edit issue comments, all without touching your secrets vault. The principle of least privilege demands we treat the default token scope as a misconfiguration, not a convenience. Most workflows only need read access, and that is all they should receive. GitHub Actions provides a first-class way to restrict the GitHub_token, the permissions key. Setting permissions at the workflow level with contents read disables every other scope by default. Pull requests, issues, packages, all of it goes to none unless explicitly granted. Individual jobs can then declare exactly the elevated access they require, creating a clear, reviewable record of what each job is trusted to do. This layered approach means a compromised step in the build job cannot write to packages, and a compromised deploy step cannot create issues. Least privilege becomes structural, not aspirational. GitHub's permission system covers 11 distinct scopes, each accepting read, write, or none. The contents scope controls code checkout and release creation. The ID token scope is a special case, it enables OIDC-based cloud authentication, replacing long-lived credentials with short-lived tokens issued by GitHub itself. Setting any single permission key implicitly sets all unmentioned keys to none, which is exactly the behavior we want as a security baseline. When auditing a workflow, scan for any scope set to write and ask whether the job genuinely requires the ability to modify that resource. When a workflow references an action as uses, action/checkout at v4, it is making an implicit promise that resolves differently every time. The v4 tag is not a fixed snapshot, it is a pointer that the action's maintainer can silently redirect to any commit at any time. An attacker who gains repository write access inherits the same ability. Your workflow checks out the same tag name, but the code it executes may be entirely different from what ran yesterday. There is no diff in your repository, no notification, no way to detect the change without inspecting the action's external repository directly. Mutable references are a standing invitation to this class of attack. A commit SHA is the cryptographic fingerprint of a specific snapshot of code. It is mathematically impossible to change the content a SHA points to without changing the SHA itself. Referencing an action by its full 40-character SHA means your workflow runs exactly the same code every single time, regardless of what happens in the upstream repository. If an attacker moves a tag or a maintainer ships a regression, your workflow is completely unaffected. Updating to a new version becomes an explicit, reviewable change in your own workflow file, creating an audit trail and human checkpoint that mutable tags entirely bypass. The TJ Actions attack unfolds in 5 steps that take less than a day to affect the entire ecosystem. An attacker obtains write access to the TJ Actions/changed files repository, then pushes a new commit containing JavaScript that iterates over process environment variables and writes them to standard output. The v35 tag is moved to point at this malicious commit. From this moment, every repository that runs a workflow using the @v35 reference executes the malicious code with full access to the runner's environment. The actions_runtime_token, a temporary credential granting GitHub API access, is exposed in public workflow logs. Had every consumer pinned to a SHA, step 4 would have produced an error instead of a breach. SHA pinning solves the security problem but introduces a maintenance challenge. How do you know when a pinned action receives a security patch? Dependabot is GitHub's answer, an automated dependency update service that monitors your pinned action SHAs and opens pull requests when new versions are released. Each Dependabot PR shows the exact SHA changing, links to the release notes, and gives your team a deliberate review checkpoint before any update lands. The combination of SHA pinning and Dependabot achieves what neither can alone: immutable references that stay current through a transparent, auditable process. Enabling Dependabot for GitHub Actions requires a single configuration file at .github/dependabot.yml. The package ecosystem field set to GitHub Actions tells Dependabot to scan workflow files rather than package manifests. Setting directory to / covers all workflows in the .github/workflows directory. A weekly schedule on Monday mornings balances security freshness against PR noise. Daily updates for actions would create constant interruptions in most teams. The groups option consolidates all action updates into a single PR per cycle, reducing review overhead further. Add labels and assignees to route these PRs directly to whoever owns your CI security posture. Supply chain hardening secures your dependencies, but there is a second attack surface living inside your own workflow files: script injection through untrusted input. A pull request title, an issue body, a branch name, all of these are attacker-controlled strings that frequently appear in workflow runs. When these values are inlined directly into run blocks, the shell interprets them as code, not data. An attacker who opens a PR with a carefully crafted title can execute arbitrary commands in your CI runner, which holds your cloud credentials, deployment keys, and access to your secrets vault. The vulnerability requires no compromised dependency, just a workflow that trusts user input. The fix for script injection is a one-line change in how you structure your workflow steps. Instead of inlining an expression directly inside a run block where the shell receives and interprets it as code, you place the expression in an env block as a named environment variable. The actions runner evaluates the expression and writes its value as an environment variable before the shell ever starts. When the shell references that variable using $sign syntax, it treats the contents as pure data, not executable code. Shell meta characters become harmless string characters. This pattern costs nothing in complexity and eliminates the entire class of injection vulnerabilities in one motion. OpenSSF Scorecards provides a continuous, automated security health score for your repository across more than 20 distinct checks. It examines whether your dependencies are pinned, whether your token permissions are minimal, whether code review is required before merge, and whether branch protection is enabled, then publishes a score from 0 to 10 alongside per-check remediation guidance. Running as a GitHub action on a weekly schedule, Scorecards outputs results in Serif format that integrates directly with the GitHub Security tab. For open-source projects, a published scorecard badge signals to consumers and auditors that your project has been evaluated against industry security standards. It is becoming a standard trust signal in the ecosystem. A production-hardened GitHub action setup combines multiple layers of defense. Pin every third-party action to a full commit SHA and maintain those pins with Dependabot. Set minimum permissions at the workflow level and grant elevation only at the job level where justified. Restrict the pull_request_target trigger to workflows that absolutely require write access on fork PRs. It is the highest risk trigger in the platform. Use environment protection rules to require human approval before any deployment to production. Enable GitHub secret scanning to automatically revoke any credentials that accidentally reach a log or commit. And run actionlint in CI to catch injection vulnerabilities before they ever reach a deployed workflow. Let us test the core concept from this chapter. 4 ways to reference the same action. Which one actually provides supply chain protection? Option A uses a version tag, which is exactly the pattern that made the TJ actions attack possible. Option C uses a branch name, which changes with every commit to that branch. Option D uses the word latest, which is not even a valid reference for most actions. Only option B, a full 40-character commit SHA, is immutable. It cryptographically identifies one specific snapshot of code and cannot be redirected without a visible change in your workflow file. This is the only reference you can fully trust.